Hello everyone. So today in this video we are going to talk about Hilbert space and complex numbers. Now you might think what complex numbers has to do with quantum computing. So let me tell you, the whole concept is based on complex numbers and 3D geometry. So you need to know some basic concepts, and if you already know, then please revise it through this video because some of the concepts are very basic. And the idea of Hilbert space will be explained, which is an important concept in quantum computing. So what are complex numbers and what was their need? If we see the classical number line, that is from minus infinity to plus infinity, it works very well and all our mathematics revolves around this. But later there was a question, like if we want to do a square root of a positive integer, then it was very possible. Not a positive integer but any positive number, it was simple, it could be done. But when we take a negative number, it was very impossible to do it. Some people make a mistake over here. They say that the minus 2 would be the root of minus 4. Actually minus becomes plus and it would be plus 4. So it was very difficult to solve this problem on this number line. Basically the limitation was this number line, so a new dimension was introduced. This is a completely new dimension. We can't see it in real life. We can't say that there is I number of oranges or I number of apples. It is an imaginary number, but it was a new dimension introduced in mathematics where this complex number could be represented. As you can see that it can be shown as a vector. For example, it has both real part as well as a complex part, and complex part is represented on the y-axis. Same minus of negative of complex numbers can also be represented on this line. So it is a vector, we can see it is very much a vector. It can be broken into components using trigonometry, and if we say that length of this vector, for example the length of this vector is 2 units, then it can be broken into trigonometric expressions in this manner: r cos theta plus r sin theta with an I, which is the complex part of the number. And it can also be represented in the form of an exponential expression that is shown over here, e to the power I theta. Over here, as you can see that both the x and y axis have a 2 and 2 length, so the angle becomes 45, the theta over here, and we can say it is pi by 4. As I told you in the previous video that ket of a psi, which is a wave function, it can be broken into two elements of alpha ket theta and beta ket 1, which was the probability of a state. Here it can be represented in the form of an exponential complex number, which we will be talking about in detail in the later videos, which is a very important concept for research. This is a basic concept of complex number that we will be needing in the later part of the videos. This is basically used to find the probability of a particular quantum state. Here a complex number, if it has a real part and b complex part, then the mod of that particular complex number would be under root of a square plus b square. And later on the probability will also be found using this formula, where a probability of a particular state is actually the square of this mod part. So it will be the whole square of under root a square plus b square if we want to find the probability of a particular qubit state. So now coming to Hilbert space, it is a fancy name of just describing a 3D vector space. It is nothing bigger than that. You can imagine it as a sphere which has 3 axes, x, y and z. It is a 3D object, that's why it is a 3D vector space. Hilbert space is just that, it is a vector space in which the quantum states can be expressed more easily and properly, because it has infinite points and each point on the sphere is actually a quantum state. That is quite possible. As I told you, this is a generic form of a quantum state that has both alpha and beta, which are the probabilities of these ket 0 and ket 1. This is just a one base in this Hilbert space. Actually there are two more kind of bases in this Hilbert space that I'll be talking about in the later videos. If you don't know what a base is, so base is actually a kind of representation or extrapolation. One vector can be shown in different ways. For example, a mirror image of a vector is also that vector only, something of that sort, not exactly, but yeah, if I want to explain basis in a simpler language without having a prior knowledge of linear algebra, then that would be a basic idea of a base. So stay tuned to the channel. Please watch the next upcoming videos to learn more about quantum computing. Thank you.